Hey guys, this will be video 5 for the how to restore a 69 SG, and this guitar is going to become a custom. This is basically going to be video 5 of this series, but there's a possibility I'm also going to upload this later on as to how, and title it, how to install a set neck um, into a body, a flat top body, regardless of how thick that body is or how wide that body is. It's irrelevant. We're just working off a center line. But this is going to be a continuation of video 5 or the continuation of the how to restore this guitar, because I did not get to go into detail about the actual installation of the pieces that I machined. And this is such a unique job that I've never done and never seen done, that this has got to benefit someone greatly. So it might get a little bit long and detailed and tedious. So as I've mentioned, my videos are not for entertainment, they're for true vocational consideration. So if you're really wanting to know how to do this type work, just stick around, and in a minute I'm going to be mixing up some epoxy and gluing this in and show you how to do this and how to walk away from it successfully. Now, last night I went ahead and epoxied that little flat bottom in, which is actually radius 3/8. It has a 3/8 inch radius on either side, because see, this was a 69 body that had the deep V machine work, which is pretty chintzy. So the client and I agreed that we wanted to turn it into more of like a 68 or pre-68 tenon, where it's truly S4S. So that ended up being two different components. This little bottom piece that I just mentioned with the radius on either corner. So that'll show you what was actually epoxied in. And then obviously before that got epoxied in, I drew a pencil line on the bottom and then cut this off on the miter saw so that this is not epoxied in and sticking out. And then I'm out here trying to cut this off and run the risk of tearing up my original heel. That's what instigated this repair, so that every bit of this repair is done with little bitty pieces that you're actually working down on the table saw and your sanding block, where I'll be cutting along this line here and then chopping off right there. It'll just be a very small little, it's like a little cove mold is basically what it boils down to. So, and then it will be getting glued in right here, and then you'll be flipping around on this side and epoxying this one in over here. And I'm actually going to do that in real time in this video, because I want you to see the importance of all the different steps you want to take. And in the event I forget, you want to make certain that you wax your alignment tools so that if any runaway epoxy is in there, it will not glue to your alignment jig. Okay. So with respect to, I may show this guitar in a little while and just talk about the difference between the 58 Explorer type design versus this one. So if anything, that's why it's on the table. But this one was very humbling in that I'll shoot right straight with you. I came out of the gate kind of with the assumption that it was going to be identical to the Explorer design. It's not. It's not. The actual, I'll try not to spend too much time with this, but I'll only cover it briefly. That one would think that the fretboard would mount like that right there directly to the bottom. It does not. It's up almost 1/8 of an inch. It's a little bit higher. So it's really deceptive. If you're not careful, you'll get yourself in trouble and you'll have this too low. And then your neck pickup will be bottoming out, or you'll be in here with a file and grinder cutting off legs, or either cutting off Philister. I think they call those the Philister screws or whatever they're called. Excuse me, the pole pieces. We don't want that. And that's why I've got this little block on here. And this is for the client, Eric. I had mentioned to him there's going to be a possibility you might have to go with short legs and do just that, shave off those screws. But I've designed this layout based on all the vintage pictures that I saw, so that you will be able to use a long-legged pickup in this body. And that lets me know that this body was designed to receive just that. Okay, and that's it bottomed out. And in all actuality, once the guitar is finished, this is going to be up about a 1/16 of an inch. It's fairly high, and I think that's most likely why they raised this up, because this guitar is already so thin in this area right here, and maybe they didn't have short leg pickups, and they were thinking, well, man, we got to figure out some way to get this pickup in here, but without this being a 1/16 of an inch paper thin. And then the solution was, well, we just build it just like we've always built our archtop guitars. The archtop guitars, they're about 3/8 of an inch higher, and they're lifted up. And then on the archtop guitars, they're actually pitched on a steeper angle. So all they did with the SG, they just raised this up about 1/8 of an inch to allow for the minimalist design that they were already working with, so that they could work with that 50s pickup, most likely the long leg pickup. Okay, because we know that this was already being used in the early Les Pauls, which were the thicker guitar. So on that note, or with that said, this whole installation is kind of working from that pickup height right there. And I went ahead and machined a little piece of pick guard material there that would actually fit around that sufficient that everything could float and move or bind. If it's going to bind, I want to know that it's binding, either binding with the body or binding in I didn't want it binding in the pickup surround or the template. So what we see right here, even in the 60s guitar, this pickup projects above this pickup guard surface right here about another almost a 1/16 of an inch. They come out of the body fairly high, but I'm just showing you, especially Eric, the client, that it might only be about another 1/16 of an inch higher than that, and it's still going to feel incredible based on the pitch that we've got. And I was talking about going with a 2-degree pitch on the bottom of this. I changed it to 2.5. So I did exactly what I said I was going to do. I glued it back to the jig temporarily, with like a temporary glue, like a CA glue, put it back on the miter saw and changed it to 2.5 degrees, then dry fit this and started verifying the assessment and the pitch, and it was spot on. It was beautiful. The reason I decided to go with the 2.5 is because I found a lot of different information that said that it was either a 2-degree pitch or it was a 3-degree pitch, and then I've heard some information where it's like, oh, it's a 3.5-degree pitch. I don't think that. I don't think it's 3.5, because I tripped up on so much other information where you would do a search and it was like, what's the neck angle, neck and body angle on an SG? And I was finding information like 5 and 7 degrees, which is ridiculous. So that's inaccurate. So if you're working with an SG, plan on being around 2 to 3 degree neck angle pitch. And I'm talking about, you guys that are here, you already know what I'm talking about. But I'm talking about this pitch right here. So I went with a 2.5 degree pitch, epoxied that bottom in, but did not do the sidewalls, primarily because when I was using this device right here, this little temporary jig right here, when I did the initial epoxy work, the only thing I don't like about epoxy, if you're not paying really close attention to it, it'll creep, or it might start rolling or something like that. So when I was fitting this, see, I had this little medallion on the back, and between that I use that medallion when I glue in every one of my necks. It has a little bit of faux guitar case material on one side, so it doesn't leave any sort of indentation. But then I came in with this little welder's clamp right here, and you would think, okay, well, so you just clamp that right there. No, that's dangerous, because it still runs the risk of rolling a little bit, and we can't have that. So what I did was, after the epoxy is on that piece is going in, I lay this piece across there perfectly, then came in And keep in mind, it's got that epoxy in there. It's wanting to slip around a little bit. And that's fine. If it does that, just go ahead and put a little bit of tension on it and squeeze the excess epoxy out. Then remove this, take it all apart, and even clean out the squeezed out epoxy, because all you want that little member fillet that you glued in to pretty much kind of bottom out and actually not be floating on any bed of epoxy. Okay, but with this guide right here, then you're able to sight down the body. I was actually just looking down it and asking myself, okay, does it look like it's perfectly flat? I mean, perfectly parallel in this direction. Visually, it looked exceptional, but one way you can verify is to do things like this. You can slide this up here and verify where it's hitting on the bottom of that board, and if it's below it, which it is, because see, this is higher, this is sticking up out of the body. So if you reach up here and verify that distance right there, let's say it's 1/8 of an inch. I'm sorry. Let's say if you're looking at, well, it's probably closer to, we'll say it's 3/16 of an inch. Well, then you want it to make certain that it's the same on the other side. Okay. So let me keep moving forward. But so I glued that piece in first, and then got to thinking about it this morning because I was getting ready to just do this right here. I waxed that so nothing can glue in, and I was already taking my piece that I machined on my tabletop router and fitting that in that location right there. Okay. Make sure the pickup doesn't fall apart. Doing the best I can here. Let's see if I'm in the camera. Okay. I think you see our intent. But I got to thinking, I thought, my God, this would make a great video. Even though it's kind of chaotic and long-winded, it would make a great video that someone could kind of see what it takes to do this, but also how it guarantees that you're not up here atop this vintage guitar with a router and run the risk of kissing that or kissing that or kissing that in a way that you don't want to. In other words, losing your guitar. So if you make all these little pieces here, now you're just very gingerly gluing them in there. And that could have been done with a tight bond. And there was a part of me, I came so close to gluing that in with tight bond because it would have been immediate. It would have tacked within like 5 minutes. And then I would have been guaranteed that I could have visually watched it to make certain that it didn't creep. But the epoxy is so much stronger, because right now that Honduran mahogany that's glued in there is quarter sewn, this little piece that I keep showing. And I covered all this in video for this series, which was also an hour long. And I didn't do any of this glue in until the very end of that video. And I know that 99% of the people that watch these videos, they don't make it past the first 5 or 10 minutes. And the only guys that do watch the whole video, they kind of have to suffer through all the conversation of, well, what if we do this? What if we do that? What if we don't do this? What if we don't do that? And there's just so much, information that unfortunately, right there at the last, I didn't even know I was going to be gluing that in or epoxying it in, or not epoxying it in, but cutting it and fitting it in. And I did. So with that piece in first, and we're in good shape, it's perfectly level and true. So what has that accomplished? We have accomplished our roll axes, or our platform. Now all we got to do is just follow the sides that are in there. And quite frankly, I could go ahead and machine the neck and fit it in and just do all the fitment for the neck and leave these out. Just leave them out. And if you want to know the truth, that probably would be the easiest. Just go ahead and fit this, and then once your neck is truly in, because see, you might elect to come in here and put a shim in here. We use this guitar pick, but I would use like a little maple veneer. You might elect to put a maple veneer shim in there to raise it up another 1/64th or something like that. And then therefore, if you had have already installed these and cut them off flush with that point right there, well, now they would be too low. And then you would be adding a piece of mahogany shim atop that, and you might see that glue line. It's not something you want. So just know that I've already done all of my engineering, and it's going to be fairly safe for me to go ahead and glue these in, but I'm still going to leave this about a 1/16 of an inch higher than it needs to be, so that once that neck is fitted in, then I'm actually flush cut sawing off this piece on the side to actually follow the pitch of the mahogany neck and the tenon, and then actually be a guaranteed one fillet addition to this part right here to achieve the vintage Gibson design, where there is a fillet piece under there that raises the whole neck lower up about 1/8 of an inch. Okay, so very complex little guitar. This thing is like off the charts. I had no idea it was going to be this complex, but this is the first SG that I've ever fully restored like this, and I've never built one per se. I've only assembled other SGs or old SGs and turned them into, or did conversions and stuff like that. So I'd never really paid any attention to that stuff right there. Okay, check the time. Okay, 16 minutes. Let me get a drink of coffee. So that's one thing. So once you've achieved your roll platform, and your pitch in one shot, now just to make certain you're really on the correct page. So you wouldn't want to use this used fretboard here because these frets are worn out. So by now you have accomplished, you have received a few drops left over from building other necks and working on guitars. So always just have a little sample piece with the fret in that you like to use. Therefore, when you're getting ready to straight line atop this and verify the bridge height, well, you can actually do something like this right here, and this is exactly what I did. But that magic number is 5/16 of an inch. That's not 5/16 of an inch from the back to the top of the fret, but from the back of this to the bottom edge of the string, it is 5/16 of an inch. And what I typically do, let me just simplify this. Sorry. This is like trying to corral a cat or a bunch of cats. What's the phrase? It's like trying to corral a bunch of cats. Okay, I just cut a little board that's 5/16 of an inch thick, put it atop this, and let's say this was 1/8 of an inch too high. Well, then you simply go over to your table saw and you shave off 1/8 of an inch of that. Does that make sense? It ought to make sense. You would just shave off 1/8 of an inch of that right there until you start lowering it. And if you want to know the truth, when you're building your guitar, you ought to do that. If your target is a certain dimension, then go for that dimension and add at least about, just to be safe, about 1/8 of an inch to it. In other words, go in high and then work your way down, because you may have missed your pitch by 1/4 of a degree, and that's irrelevant. If it's 2.3 degrees or 2.6 degrees or something like that, that's already done because that piece is epoxied in. But all you have to do now is just adjust the height of this as it goes in by shaving off a little more material. Or if you shaved off too much, don't put a guitar pick in there, but use that maple veneer and come in and do a little veneer shim. Wood. Make certain that it's wood. Don't put any plastic in there, but do a slight shim in there to raise it back up. Okay, but back to rockabilly. With this right here, you can now use your straight edge and come across this, and look at that. You go right through the slot of your D string location, and you're sitting perfectly flat here. You can assess the clearance, the maximum clearance you could achieve if you were to bottom out that neck pickup, and then you've already verified your bridge height back here well before you. That was the initial starting point. You know, where did you want your bridge to end up? That's kind of where I'm going with this. But regardless of where you want your bridge to end up, you could achieve that by going in at a 4-degree pitch, which you wouldn't, but you'd have to bottom out so far to this that now this neck pickup would have to be buried into the body, and that's what I meant by they just brought the lower up a little bit, maintained about 2 to 2.5, maybe 3 degrees pitch, and then now you're true. And I'm sitting perfectly flat on the bottom of the platform that I epoxied in last night. So I'm ready to build this neck, or I've already machined the rough lower, but I'm now actually, if I like what I see here, then I'm ready to go ahead and trust. Okay, what I just did. Okay, could care less what that dimension is. All I want to do, I just want to create a pencil line. Now, a little trivia for you. Anytime I'm creating a pencil line that I might not be certain of, I do a dashed line. Okay, but if I'm 100% confident, I go ahead and do a straight solid line. So if I pick this up and I see a dashed line, that lets me know, okay, that may be it. But when you're working this, go ahead and go over to your table saw. You already know and also with this right here, you could also do this right here if you wanted. You could just come in, make the mark, and then make your mark right there. And then you know that's where you're going to be notching your heel. But all I'm saying is I like having these temporaries. This is not the neck, then I might machine this and start fitting this to the body so that I just get a feel for the order of operations that I'm going to be going through as well. Man, herding cats. That's the phrase. It's like trying to herd a group of cats. Okay, so when you have that information right there and you feel pretty confident, then you're ready. If you haven't done it already, if all you were working with was just a straight block right now, and keep in mind up here this was already cut on a 2.5-degree pitch, so that once it came up against that body of that guitar, it was a real nice true fit. It's not that big of a deal, but it just kind of throws you off if you look up there and you see a gap. Okay? But by going ahead and cutting that, you start getting a feel to remind yourself, okay, when I'm building this neck over here, I got to make certain that when I cut this end off, the length that I'm getting ready to install it, I need to go ahead and be planning on cutting that on the appropriate degree. Because if you're working with like a Les Paul replica, that degree is going to be approximately 4 degrees. And if you were to come in here and cut this off straight without machining that, then your tenon would end up being, it would be perfect on the bottom, but then you might end up being a good distance short visually. And it's so frustrating because there's nothing you can do about that now, because you have a stop point at the 16th or the 19th fret. And if you screw up and cut your real nice neck off too short, then it's just, it's too short. Okay, so let's mix up some epoxy, and let's actually glue this in. So I hope that made sense about your getting your pickup clearance height, as well as assessing your bridge height. And also I had this up on the table for a reason. We'll take a second to cover this, but after, when this is all in, we've already covered, I don't have to put that back in there, but when this is in and in this location right here, I'm so glad I saw that on the table and thought about it. But I know that this guitar will not be getting that pickup surround, and the pickup will be just a little bit slightly below that. Okay, but now you can assess. I'll see if I can hold this up in the camera without it falling apart. I don't. It's gonna fall apart. Sorry, guys. It's just hard to do this crap on camera. But if you see my point, what I'm trying to do is get a visual for the string path, PATH, and is it going to be clearing properly? And it is, because if you look at the vintage pictures of these guitars, even though they are the flat surround right here, and they don't have the actual, like the Les Paul type surround, this back pickup, the bridge pickup, man, it really projects out of that body quite a bit, and almost to the point where it projects out too much, but it projects out about that much back there. It's pretty extreme. But is it unattractive? No, because that's their original design. And the last thing you would want to do is restore a, very extremely valuable guitar, and then you miss this back here, and that bridge pickup is only sticking up about that much. And then when it goes to the auction, 20 years from now, and they do an evaluation on it, it's kind of confusing how the pickups in this guitar, if you did it wrong, would be a eighth of an inch lower, and it's not. It will be identical to the actual 60s guitars where it sticks out kind of far. Okay, and that is all based on the fact that the bridge pickup, the actual bridge itself projects out of the body about an eighth inch higher than this guitar over here. And what is that for? Where's my pickguard? It is because this pickguard is actually under and behind. It goes behind the bridge a little bit. It goes all the way around. In other words, when you're looking at the bridge, you don't see the body top, and you got to make certain that this bridge comes out of the body about an eighth inch higher, also to accommodate the old vibrola, the Maestro Lear vibrato, which is acting like a almost like a B6 Bigsby, where you're working with a break angle. So you don't have the luxury of going into a hardtail. You're actually traveling on a slider break angle. The break angle is going to be about right there. But if you had have dropped this bridge down an eighth of an inch lower, well, then what would have happened is your break angle would have ended up being way too minimal, and you run the risk of getting harping back there. And I've already covered this stuff in video 4, but when you look at this guitar right here in its finished state, then that's what you want to see. See, you want to see, basically, it's kind of funny. If you want to know what the dimension is, it's kind of irrelevant. It's a bamboo skewer. And what that engineers out to be is roughly 14 millimeter from the top of the guitar to the top of the bottom of the D string. Okay, so it's roughly 14 millimeter is the finished guitar. And not only is it beautiful, but it plays and feels like a 1958 Explorer or Flying V or something like that. And you might think, well, the Explorer has a pickguard. Well, yeah, it does have a pickguard, but not back there. The pickguard goes back in this location right here, and that's the only pickguard that you have anywhere near the vicinity of the actual bridge. The rest of it is acting as just an area without a pickguard. So this one has the pickguard surrounding it, so it has to come out of the body about an eighth of an inch higher. That accommodates the vibrato, because this guitar, if it ever had a vibrato, it had to have the V5 Bigsby, which had the string retaining bar, the hold down bar. But that became a bit of a nightmare, because then the break angle was a little too extreme, as it was going under the retaining bar of the B5. So it was this whole hit or miss of, damned if you do, if you don't, situation where, well, it's just, at least it looks good, and if it'll sell the guitar, then so be it. But nonetheless, let's do some epoxy work. But just take note of that. And what this boils down to, because you're looking at minimal dimensions. This is pretty important. You're looking at this minimal dimension right here. So if anything, see, I could actually go ahead. I could go ahead and make a pencil mark right there. And if you were dealing with a situation where you had just minimal wood, then go ahead and build your neck out of poplar, not the whole neck, but just this part out of poplar. And if you can engineer it to work properly right here with that dimension right there, then you can ask yourself, okay, well, what is the bare minimum that I can get away with to build this guitar? And whatever this bare minimum is, make sure you add about 1/8 of an inch to it, because you're probably going to screw something up. But right now I'm looking at, roughly like 1 1/4 in that area, because it's tapered on the front, it's tapered on the back. Even though the guitar is thicker than that, it's very deceptive. If your body was 1.5 inches, you might be able to get away with a 1 3/8 inch thick piece of material right here, because it's all getting tapered and coming together. Okay, that ought to make perfect sense. But wasn't something I was planning on talking about. But I could go ahead and actually put this on the table saw and machine off that amount right there, so that when I am preparing to machine out the final neck, then I'm just laying this in this location right here, and then making a pencil mark, at least to get me started. And then I'm going over to my table saw and beginning to rough that material out. And then my miter saw, which way would it be? It's going to be pitching that way. So my saw is a compound miter saw, so it will be angling this way. So I'll be cutting. Is that right? I'm almost losing myself here. No, that's correct. So you'll be holding it on the left side of your miter saw fence. That's correct, because it'll be pitched like this right here. So if you wanted to, on this top cut up here, you could go ahead and cut that on a 2.5 degree, because see, that's cut on a 2.5 degree right there. That's cut on a 2.5 degree, or a 2.5 degree in. Therefore, when I'm beginning to fit this, I'm really making a real good judgment as to what dimensions am I truly working with. Because after it's all said and done, and I get a real nice fit here, and I'm getting really close to finishing this neck and ready to install it, I'm going to come in here and I'm going to shave off about another paper thickness here, so that when I'm getting ready to epoxy this neck in, the last thing you want is to have a beautiful fit right here that is creating a gap on these 3 sides. So I can't get a piece of paper in that right now. After it's all said and done, and this is actually cardboard. This is too thick, but just like a piece of notebook general paper, I say that's too thick. That's okay. That's probably 1/64 of an inch, maybe a 32nd. But after you slide this up in here and make contact around the sides, you want to be able to slide that paper out and it not go click. You don't want to hear it go. Let me see if I can get it to do it. See, if it's clicking, that's letting you know that it's not making contact right there. So you not only do you want to be able to pull it out with ease, but you want to actually be able to push this up in here and hold it, and then slide the paper down in there. Just on this end, not on the sides. If you get them off on the sides, then you'll lose your whole yaw axis, or the possibility of your center line. So I hope that makes sense, because I won't be gluing this neck in for a few days. Probably won't be doing that on video. But just know that if you're going to sacrifice a little bit of material, sacrifice it on the very end. And see, sometimes you're actually working with a tenon that is radiused. Actually, most of the time you are. This is a very weird, strange design. You're typically always going to be working with a radiused tenon. and you will want to be able to have the paper even slide around the corner and not bind. Therefore, you're only making a real tight fit on the sides. And then when you are pushing your neck in, gluing it in, you're kind of, especially if you're epoxying it, you're pushing out the excess glue, and that's where all the glue is squeezing out. You're cleaning it up, discarding it, cleaning it up, and then once you finally feel that, you'll never hear. If you hear that click, you better be hearing the click where it's hitting right here, not back there. That's the squeeze out location. Okay, but after the guitar is built and it's really beautiful and ready to be, oh hell, you can't see it, sorry. See all that epoxy squeeze out right there? That's not a gap. What that is that's just all the excess epoxy squeeze out from the build of this guitar. And if you were to look at it when it's machined, you would see a really beautiful tight join, in the sides and in the end. Okay. Check the time. 36 minutes. I'm surprised it's not an hour and a half. It's a lot of information though. All right, now let's mix up some epoxy. And let me pause and get the table under control, and then get a drink of water. Then we'll mix up some epoxy, and we will start gluing in these little fillets on this side and on that side right there. And that will achieve our S4S tenon that is pitched, or mortise that is pitched 2.5 degrees, and it's straight up and down in the back, and will make for an exceptional build. So let me pause, and we'll get started after that.